At the end of this video, you should be able to compare the radiative and convective zones of the Sun and describe the three layers of the Sun's atmosphere. Chapter 29, Section 1, The Sun's Interior. Scientists can't see inside the Sun, but computer models have revealed what the invisible layers may be like. In recent years, careful studies of motions of the Sun's surface have supplied more detail about what is happening inside the Sun. The parts of the Sun are shown on the screen here. The core. At the center of the Sun is the core. The core makes up 25% of the Sun's total diameter of 1,390,000 kilometers. The temperature of the Sun's core is about 15 million degrees Celsius. No liquid or solid can exist at such a high temperature. The core, like the rest of the Sun, is made up entirely of ionized gas. The mass of the Sun is 300,000 times the mass of Earth. Because of the Sun's large mass, the pressure from the Sun's material is so great that the center of the Sun is more than 10 times as dense as iron. The enormous pressure and high temperature of the Sun's core cause the atoms to separate into nuclei and electrons. On Earth, atoms generally consist of a nucleus surrounded by one or more electrons. Within the core of the Sun, however, the energy and pressure strip electrons away from the atomic nuclei. The nuclei have positive charges, so they tend to push away from each other. But the high temperature and pressure force nuclei close enough to fuse. The most common nuclear reaction that occurs inside the Sun is the fusion of hydrogen into helium. The radiative zone. Before reaching the Sun's atmosphere, the energy produced in the core must move through two zones of the Sun's interior. The zone surrounding the core is called the radiative zone. The temperature in this zone ranges from about 2 million degrees Celsius to 7 million degrees Celsius. In the radiative zone, energy moves outward in the form of electromagnetic waves, or radiation. The convective zone. Surrounding the radiative zone is the convective zone, where temperatures are about 2 million degrees Celsius. Energy produced in the core moves through this zone by convection. Convection is the transfer of energy by moving matter. On Earth, boiling water carries energy upward by convection. In the Sun's convective zone, hot gases carry energy to the Sun's surface. As the hot gases move outward and expand, they lose energy. The cooling gases become denser than the other gases and sink to the bottom of the convective zone. There, the cooled gases are heated by the energy from the radiative zone and rise again. Thus, energy is transferred to the Sun's surface as the gases rise and sink. The Sun's atmosphere. Surrounding the convective zone is the Sun's atmosphere. Although the Sun is made of gases, the term atmosphere refers to the uppermost region of solar gases. This region has three layers: the photosphere, the chromosphere, and the corona. The photosphere. The innermost layer of the solar atmosphere is the photosphere. Photosphere means sphere of light. The photosphere is made of gases that have risen from the convective zone. The temperature in the photosphere is about 6,000 degrees Celsius. Much of the energy given off from the photosphere is in the form of visible light. The layers above the photosphere are transparent, so the visible light is the light that is seen from Earth. A photo of the Sun's photosphere is shown on the screen here. The dark spots here are cool areas of about 3,800 degrees Celsius and are called sunspots. The chromosphere. Above the photosphere lies the chromosphere, or color sphere. The chromosphere is a thin layer of gases that glow with a reddish light that is typical of the color given off by hydrogen. The chromosphere has temperatures that range somewhere between 4,000 degrees Celsius to 50,000 degrees Celsius. The gases of the chromosphere move away from the photosphere. In an upward movement, gases regularly form narrow jets of hot gas that shoot outward from the chromosphere and then fade away within a few minutes. Some of these jets reach heights of 16,000 kilometers. Spacecraft study the sun from above Earth's atmosphere. These spacecraft can detect small details on the sun because they measure wavelengths of light that are blocked by Earth's atmosphere. Movies made from these spacecraft images show how features of the sun rise, change, and sometimes twist. The sun's outer parts. The outermost layer of the sun's atmosphere is the corona, or crown. The corona is a huge region of gas that has a temperature above 1 million degrees Celsius. The corona is not very dense, but its magnetic field can stop most subatomic particles from escaping into space. However, electrons and electrically charged particles, called ions, do stream out into space as the corona expands. These particles make up the solar wind, which flows outward from the sun to the rest of the solar system. The chromosphere and the corona normally cannot be seen from Earth because the sky during the day is simply too bright. Occasionally, however, the moon moves between Earth and the sun and blocks out the light from the photosphere. The sky darkens and the corona becomes visible, as is shown on the screen here. Let's go through the layers of the sun, starting with the outermost layer, the corona. The corona forms the sun's outer atmosphere and can extend outward a distance equal to 10 to 12 times the diameter of the sun. The gases in the corona are so thin that it is visible only during a total solar eclipse. The chromosphere is a thin region below the corona, only 3,000 kilometers thick. Like the corona, the deep red chromosphere is too faint to see unless there is a total solar eclipse. The photosphere is where the gases get thick enough to see. The photosphere is what we know of as the visible surface of the sun. It is only about 600 kilometers thick. The convective zone is a region about 200 kilometers thick where gases circulate in convection currents. Hot gas rises from the interior while cooler gas sinks towards the interior. The radiative zone is a very dense region about 300 kilometers thick. The atoms in this zone are so closely packed that light takes millions of years to pass through. And lastly, the core. The core is at the center of the sun. This is where the sun's energy is produced. The core has a radius of about 200 kilometers and a temperature near 15 million degrees Celsius. At this point, you should be able to compare the radiative and convective zones of the sun and describe the three layers of the sun's atmosphere.